Antes de dar inicio a la ceremonia, queremos agradecer, por favor, silenciar vuestros teléfonos celulares y también les invitamos a escuchar las siguientes recomendaciones de seguridad del siguiente salón. Agradeceremos no fumar al interior del recinto y en otros lugares no autorizados. Asimismo, solicitamos, ya lo decíamos, silenciar vuestros teléfonos celulares o cualquier equipo electrónico que interfiera en el normal desarrollo. A través del Departamento de Ingeniería de Sistemas y Computación, quiere darles la más cordial bienvenida a la 14ª versión del Congreso Internacional de Computación e Informática del Norte de Chile, INFONOR 2023. INFONOR 2023 cuenta con el apoyo de Corfo por medio del Fondo de Innovación de la Competitividad Regional del Gobierno Regional de Antofagasta y también cuenta con el respaldo de la Sociedad Chilena de Ciencias de la Computación, REUNA, la Revista Chilena de Ingeniería, Ingeniar, y la Asociación Chilena de Reconocimiento de Patrones, ACHIRP, entre otros. INFONOR Chile es un esfuerzo conjunto de 4 universidades chilenas de la zona norte de nuestro país. Me refiero a la Universidad de Tarapacá, la Universidad de Arturo Prat, la Universidad Católica del Norte y la Universidad de Atacama, y que tiene como objetivo ser un punto de encuentro para presentar y debatir aportes científicos de las diferentes disciplinas de la computación y la informática, investigación aplicada e innovación en actividades tecnológico-industriales. Asimismo, durante el desarrollo de INFONOR 2023 se abordarán diversas temáticas relacionadas a las tecnologías de información, destacando las sesiones de trabajo y conferencias en ingeniería de software, ingeniería de datos, automatización y robótica, educación en computación avanzada de peligro y riesgos sísmicos. Bien, para dar la bienvenida a los presentes, quiero dejar con ustedes al director de Investigación y Análisis de la Producción Científica de la Vicerrectoría de Investigación y Desarrollo Tecnológico de la Universidad Católica del Norte, el doctor Carlos Calderón Carvajal.
Bueno, buenos días a todos y todas. En primer lugar, hacer extensiva el saludo de nuestro rector, doctor Rodrigo Alda, que bueno, por motivos de agenda no ha podido estar con nosotros en esta oportunidad. Sí. Bueno, es un honor saludarles en el inicio de este evento, el cual por más de 10 años se ha preocupado por abordar y promover una importante área de investigación y desarrollo como lo son las ciencias de la información y la tecnología. En un mundo cada vez más interconectado y digital, la importancia de estas disciplinas se vuelve innegable. Para nuestra institución, esta importante área de investigación no son meros campos aislados, sino un área transversal que tiene la posibilidad de impulsar avances en todas las disciplinas, desde la medicina hasta la ingeniería, desde las ciencias sociales hasta la industria. Nuestras vidas y la sociedad en su conjunto se ven transformadas por la capacidad del procesamiento de datos, la inteligencia artificial y la computación de alto rendimiento. Hoy nos reunimos en un espacio donde podemos conocer y compartir avances y contribuciones de nuestros investigadores e investigadoras, quienes están contribuyendo de manera significativa a redefinir nuestras fronteras del conocimiento, buscando soluciones innovadoras a los problemas a los que nos vemos enfrentados como investigadores e investigadoras y también como sociedad. Sin duda, este es un espacio donde la colaboración, el intercambio de conocimiento y la interdisciplina se convierten en motores de progreso de la investigación y el desarrollo. En los próximos días, hasta el día viernes, tendremos la oportunidad de conocer trabajos de expertos y expertas en una amplia gama de campos que han incorporado la informática y la tecnología en sus investigaciones y proyectos. Compartiremos ideas y desarrollos que nos desafiarán y nos inspirarán a seguir impulsando la innovación. Como Universidad Católica del Norte nos enorgullece ser anfitrión de esta conferencia, un lugar donde convergen destacadas investigadoras e investigadores en el campo de la informática y la tecnología, una oportunidad de abrir nuevas posibilidades, trabajo y colaboración. En este sentido, solo me queda agradecer a quienes son parte de la organización de este evento y quienes no la han sido también en el pasado, e invitar a todos y todas a aprovechar este espacio de encuentro, aprendizaje y colaboración. Muchísimas gracias.
Agradecemos las palabras del director de Investigación y Análisis de la Producción Científica, Carlos Calderón Carvajal. Seguidamente queremos invitar a todos a ver el siguiente video en el cual el gobernador regional de Antofagasta, Ricardo Díaz Cortés, nos envía un mensaje.
En la región de Antofagasta, como gobierno regional, nosotros queremos invertir en lo que significa el desarrollo de las vocaciones futuras de la región. En tal sentido, estamos trabajando para que haya un instituto de tecnologías limpias, queremos mayor investigación asociada a los salares y el litio, queremos instalar este centro aeroespacial para el armado satélite. Todo esto implica un desarrollo mucho más acreciente respecto de las tecnologías y el desarrollo de la informática en nuestra región. Vamos a necesitar nuevos profesionales que tengan esta capacidad de mirar el entorno y que sean capaces de enfrentar los nuevos desafíos. Por eso es que abrazamos esta iniciativa que están llevando ustedes acá, INFONOR Chile, en donde queremos el desarrollo de la informática, el desarrollo de la computación, el desarrollo de las nuevas tecnologías, la inteligencia artificial, manejo de Big Data, manejo de distintos tipos de informaciones a través del desarrollo de todo este potencial. Nos interesa como región ir avanzando hacia el futuro. Nosotros queremos ofrecerle a nuestros niños y niñas, a nuestros jóvenes, un futuro distinto, un futuro diverso, en donde está la minería, pero también están las energías limpias, el desarrollo de astronomía, el desarrollo de informática. Y para eso tenemos que trabajar en conjunto. Así es que un gran abrazo, espero que se desarrolle muy bien este evento y sepan que como gobierno regional estamos proyectando esta región con un sentido de futuro y con un sentido de compromiso en el desarrollo de nuevas vocaciones.
Y las palabras del gobernador regional, Ricardo Díaz. Para referirse a los alcances de INFONOR 2023, quiero dejar con ustedes al presidente del comité organizador, el doctor Claudio Meneses Villegas.
Bueno, en primer lugar, saludar a la presencia del doctor Carlos Calderón, digamos, las palabras del gobernador regional, las autoridades de la UCN presentes, los invitados internos y externos, los académicos y estudiantes que se encuentran presentes, bueno, en general a todos los presentes. Primero me voy a referir a lo que es el rol de la computación, brevemente. La ciencia de la computación y las tecnologías de la información hoy en día juegan un rol esencial en el desarrollo social y económico de los países. Por ejemplo, la creación de la red global no hace mucho, Internet, y luego la web, cambiaron en un corto periodo de tiempo, de forma irreversible, la forma en que nos comunicamos, educamos y trabajamos. Hoy en día, nuestro desafío no es cómo generar datos, sino cómo generar conocimiento útil a partir de esos datos masivos, área que se conoce como ciencia de datos o data science. Por otro lado, los recientes avances científicos en inteligencia artificial, tecnológicos en robótica, están materializando las convicciones del padre de la computación, Alan Turing, quien en los años 1940 del siglo pasado predecía que por el año 2000 tendríamos máquinas inteligentes capaces de emular el comportamiento humano, de forma de que un humano no podría distinguir si estaba interactuando con una máquina inteligente o con otro humano. Hoy más que nunca estamos viviendo la materialización de esa predicción, con la irrupción para el uso masivo de tecnologías de inteligencia artificial relacionadas al procesamiento del lenguaje natural, bueno, que ustedes más que conocen, ¿cierto?, los chats inteligentes, que de seguro cambiarán la sociedad, incluyendo la forma que aprendemos y enseñamos. Los avances tecnológicos a nivel de componentes de hardware, por un lado, y de la inteligencia artificial, por otro, han permitido la masificación de dispositivos robóticos hoy en día. Aunque sus usos principales tienen que ver con una industria relacionada con el área militar, también hay usos comerciales y sociales. En el terreno industrial, una nueva revolución tecnológica está cambiando totalmente los sistemas productivos a través de lo que se denomina la industria 4.0, Smart Industry, Smart City, etc. Esto lo vemos latente en la industria minera de la región nuestra y sin duda también se verá en la futura industria del litio de la zona. Por otro lado, no menos importante es el desarrollo de software y los procesos asociados. Estos han evolucionado producto de cerca de 70 años de investigación y de producción tecnológica, que incluyen plataformas, lenguajes, sistemas complejos de software, metodologías de procesos. Sin este desarrollo, las máquinas computacionales no serían funcionales a las necesidades de los usuarios de hoy. Nuestra región, nuestra macro zona norte de Chile, o la macro zona norte en realidad comprende también otros países cercanos, no quieren estar ajenos a estos avances. Por ello, esta 14ª versión del Congreso Internacional de Computación e Informática del Norte de Chile incluye numerosas charlas invitadas, charlas tutoriales, presentaciones de artículos científicos en temas relevantes para el desarrollo científico y tecnológico de la macro zona norte de Chile y de nuestros países vecinos y amigos. Bueno, en la versión 2023, este evento tiene un alcance realmente internacional. Primero me voy a referir al comité de programa, que tiene miembros que provienen de 4 continentes, Asia, Europa, Norteamérica y Sudamérica, compuesto por más de 40 miembros que pertenecen a 10 distintos países. Los artículos sometidos provienen de 10 países distintos, los artículos aceptados de 6 países distintos que corresponden a 3 continentes. Y otro aspecto a resaltar, digamos, que los artículos aceptados y expuestos efectivamente en esta conferencia van a ser, están asociados a una publicación en revistas Scopus y Web of Science. El evento, en cuanto a los eventos, como lo mencionaba el presentador, ¿cierto? El evento cuenta con 4 charlas magistrales, 28 charlas invitadas, 14 de ellas nacionales y 14 de ellas internacionales, 3 talleres prácticos con profesionales que vienen de Perú, Colombia y Chile, y 17 presentaciones de artículos científicos, además de 6 workshops. Eso les dará una idea de la magnitud del evento y del esfuerzo de organización que conlleva este evento. Bueno, para ir finalizando, no quiero olvidarme de agradecer al equipo organizador, ¿cierto? En especial a las personas que estuvieron a cargo del comité de programa, doctor Álvaro Prado y doctor Rafael Martínez, presentes aquí, al coordinador de workshop, ¿cierto? El profesor Ítalo Donoso, también presente aquí, al coordinador de talleres prácticos, el profesor Alejandro Peña, en especial, muy en especial, al encargado de logística, el profesor Ricardo Pérez, que está acompañado de un equipo de más de 30 estudiantes, sin los cuales, digamos, esto no sería posible. Y en cuanto a los auspicios y patrocinios, ¿cierto? Este evento, como lo mencionaba, cuenta con el auspicio de 4 universidades regionales que conforman el Consorcio INFONOR Chile, En especial quiero destacar el aporte que tuvo Corfo a través de la adjudicación de un proyecto Corfo Viraliza que permitió cubrir gran parte de los costos de este evento. Muy importante ese aspecto. También mencionar a la Facultad de Ingeniería y Arquitectura y el proyecto de Ingeniería 2030 de la Universidad Arturo Prat, que en forma extraordinaria, digamos, aportó de manera adicional al evento. Y bueno, lo que mencionaba también, REUNA, la Sociedad Chilena de Ciencia de la Computación y la Asociación Chilena de Reconocimiento de Patrones. En resumen, no me queda más que invitarlos a participar de todos los eventos que conforman el programa INFONOR Chile 2023. Muchas gracias.
Agradecemos las palabras del presidente de INFONOR Chile 2023, el doctor Claudio Meneses Villegas. Bueno, prosiguiendo con la ceremonia, daremos paso a la clase magistral inaugural de INFONOR 2023, dictada por el profesor investigador y académico, el doctor Chris North. Chris North es profesor de Ciencia de la Computación en Virginia Tech, en Blackboard, Estados Unidos. Es director asociado del Centro Sangani para la Inteligencia Artificial y Análisis de Datos. También miembro principal del Centro para la Interacción Humana-Computadora. Lidera el grupo de investigación Visual Analytic y fue el arquitecto principal del laboratorio Gigapixel Display. Ha graduado a 20 estudiantes de doctorado y es coautor de más de 140 publicaciones. Fundó el certificado de posgrado en análisis de datos y coorganizó la carrera de modelo computacional y análisis de datos en Virginia Tech. También ha trabajado para la comunidad como copresidente general del Institute of Electrical and Electronic Engineer de Infobit, para Papers copresidente y como analista de datos y conferencias de ciencia y tecnología. Su agenda de investigación y educación busca permitir una interacción efectiva entre humanos e inteligencia artificial en entornos de análisis inmersivos. Por más de 2 décadas ha liderado esfuerzos para diseñar y evaluar la usabilidad de pantallas grandes e inmersivas, espacios para visualización interactiva y análisis de texto en ciencia de datos. Damas y caballeros, dejamos con ustedes a nuestro expositor invitado, el doctor Chris North. Por favor, le invito a pasar adelante.
Testing, 1, 2, okay. Hola, ¿cómo estás? So I'm Chris North. I'm going to talk to you today about immersive analytics. But first, I want to say gracias. Thank you for inviting me to come and join you today. I'm very much looking forward to getting to know you. I've enjoyed exploring northern Chile a little bit, as you can tell, and really developing a good appreciation for the environment here. I really like it. And I'm really looking forward to beginning new collaborations with you. So let's spend some time talking this afternoon about research ideas. I also want to thank you. Also thank you for putting my name on the front of the university so I could find my way. Chris Norte. So very helped me find the location. Okay. Also, I want to thank you for sending Brian Keith to join us at Virginia Tech as a student. He was one of the best PhD students I've ever had in terms of productivity and publishing research papers together and so on. So thank you, Brian, for coming to Virginia Tech. Thank you for sending him to Virginia Tech so I could enjoy him. And I just want to tell you that I wanted to show you that we took good care of Brian by giving him this really spacious office with plenty of room for him to work at Virginia Tech. So we took really, really good care of Brian while he was there. Okay, so immersive analytics. So probably you've seen pictures like this in TV shows or movies, detective movies, where they have all this information and they're trying to figure out the mystery, right? The bad guy, who did it, right? And the question is, why do they do that? Why do they make these big boards with all this information on it? So yes, it looks cool in movies, right? But is there a deeper reason why we want to have these big boards covered with information? And that's what I'm going to try to address today. So by the end of the talk today, I hope you'll understand why this is important. okay? So more seriously, I'm going to talk to you about immersive analytics, which is a new field rising in computer science that has to do with the use of large display spaces and or immersive display spaces, 2D or 3D display spaces, to display information in an interactive way to enable people to analyze data. And so the big question is this useful? Is it useful to have these big display systems and immersive display systems to help people analyze data? Is it useful, or is it just a gimmick? Is it just a hype, right? And so we're going to try to do some science to understand why this is really useful, okay? And so what we want to talk about is how these displays are useful to support analytics. And so this is a picture of what we like to call the sense-making process. It's the process people go through when they're analyzing data, right? People start down here with gathering data. We call this the foraging loop, gathering data, right? And then they go into what I call the synthesis loop, connecting data, making structures, right? Finding patterns in data, right? And then finally presenting the results of that data, right? So that's kind of what we call the sense-making process of how people make sense out of information. And so what we want to do is use all these types of display systems to help people do this sense-making process, okay? And so the question is why are these big displays useful for doing sense-making? Well, it comes down to this notion of embodiment. So embodiment is a theory in psychology that says that the mind and the body are tightly connected, that we were designed to work together, our mind and body, that we think with our mind and our bodies together, not just our minds, okay? And we call that notion embodiment, okay? That we're people with physical presence, not just mental presence, okay? Both, ambas, right? And so what I want to talk about is why these large display spaces enable embodiment and how that enables analytics, human sense-making, okay? And the argument I want to make today is that immersive display spaces play 5 roles in helping people do data analytics. They help provide space for embodied visualization, seeing information, interaction, interacting with the information, cognition, thinking about the information, collaboration, working together with other people on information, and finally, AI algorithms, helping us interact with AI to solve problems in data analytics. Okay, so I want to talk about those 5 levels of how big display spaces help us do these things with information. Okay, so I'm going to talk through those one at a time. So first, embodied visualization. So this is the biggest bar chart you've ever seen, okay? So if you were to look right there where he is pointing, you would see a bar chart, right? But there's millions of bars, right? So big data set, right? So for students that are interested in mining, geology, think of this as like imaging, right? Just over a sensor, right? Data about maybe the surface of the Earth or under the Earth, right? And so you have millions of data points, and you want to understand the patterns, right? And so when we have a very big display like this, we can display all millions of data points. If I only had a small display, I could only display a few data points, right? So if I have a big display, then I can navigate it physically. I can look over here, right, to look at here. And I can move over here, right, to look over here, right? And I can go like this. I can use my body to navigate the information. We call that physical navigation. In contrast, on a small display like a laptop, if I were to display millions of data points, I would have to scroll and zoom, right? We call that virtual navigation. You see the distinction? Big display, I can physically navigate. small display, I have to scroll and zoom. Right? What's the difference? Well, the difference is the bigger the display, the faster I can navigate. Because physical navigation is faster than virtual navigation. Okay? So as I make my display bigger and bigger, I can solve various visualization tasks faster and faster. Okay? So these are visualization tasks that are like find the largest data point, or find a pattern in the data, or those kinds of visualization tasks. Right? And so when we give this to people, people perform faster when they use the physical navigation and slower when they use the virtual navigation. Okay? So by enabling people to navigate the data physically, we can speed up their performance in accomplishing data science visualization tasks. Does that make sense? Cool. And so this notion of physical navigation is really important, and that's what these large display systems enable us to do. This also works in 3D displays. So this is a bunch of, this is a computational notebook. Do you know what Jupyter notebooks are? Yes? So this is a Jupyter notebook, many cells in a Jupyter notebook, spread out in 3D. This person is wearing a headset, VR headset, so they can move around, right? And they can see all the cells around them like this, right? So physical navigation, right? If I want to look at this cell, I just turn my head, right? If I want to look at this cell, I just turn my head. Compare that to virtual navigation on a small screen where I have to scroll up, scroll down, scroll back up, scroll back down, right? And so if I compare the performance time of a user doing a data science task in a notebook, it's faster with the VR and slower with a regular laptop display, desktop. Okay? So the physical navigation enables me to access the information much quicker than scrolling through. Okay? And it's faster for a couple of reasons. It's faster because it takes advantage of spatial memory. I can remember where things are. It takes advantage of very quick motion, right? And it takes advantage of, so when we talk about spatial memory, it enables us to remember where things are with respect to our body. So I can remember, oh, I want that cell that has the clustering algorithm. Ooh, that's that one, right? I can remember right where it is. So that makes it a lot faster. Okay, so that's kind of like the base of why these displays are important for visualizing information. It all comes down to this notion of physical navigation. And it works also in hybrid displays. So we call these hybrid. This is a physical monitor. And these are virtual monitors from a headset, right? So I have both, physical and virtual. So now if I have my laptop and I have a headset, I can have my laptop, good high-resolution display, but now I can make it bigger by having a virtual display also at the same time. Right? Now, why would we want that? Why would we want both physical display and virtual display? Well, it turns out that our physical navigation is faster on physical displays than on virtual displays. Okay? Why? Well, it's because the resolution of the virtual display is less than the resolution of the physical display, and therefore the information has to be displayed in a bigger physical size. And therefore, with a virtual display, we can display a little bit less information than with a big physical display. Does that make sense? And so what that means is I have to physically navigate more when I have these kind of virtual displays than when I have physical displays. It's still faster than if I just had one small display, but the fastest is physical displays. The second fastest is the virtual displays. The slowest is just one small display. Okay? Make sense? So we can do science and compare all these things by measuring user performance time on these tasks and see which one is faster and which one is slower. Okay, so now we go to embodied interaction, right? So how do we interact with the data? And so you can play the video. And so what we're going to see here is the idea that her interaction with these data points is based on her distance from the display. When she stands far away, she can manipulate groups of data points, right? But as she moves closer, see, she steps closer, see the interaction points get smaller, and now she can interact with individual data points, right? So her interaction is based on her physical navigation. If I stand back, I see the big picture, and I interact with large-scale information. Right? When I step forward, I see individual data points, and I can interact with individual data points. Okay? So the interaction is based on the distance from the display. So we call that physical navigation aware. And this is important, so now we can interact at different levels of scale in our data by exploiting our physical navigation. And so what we find is this is also faster than if we force the user to select or to somehow control their scale of interaction using some interaction technique. So in other words, what we find is that when we ask people to manipulate this kind of information, and we do not give them this kind of control, and we force them to choose their size, we find that the size that they choose correlates with how far away from the display they are. So what that means is their distance from the display predicts the scale at what they want to interact. So that means we can automate it and have them interact on the scale automatically based on their distance from the display. And that saves time. That's more efficient from both a cognitive and an interactive point of view. Okay, so now we're doing this using multiple sensors. So we have a sensor in the room that's tracking the room, and so the wands that she's holding is tracked in the space so that she can control it using this, what we call a ray casting technique, where we draw a line and figure out where that intersects the display and use that to manipulate the data. Okay. Now, this idea of interaction extends to lots of different situations where we want to manipulate lots of data at the same time. So here's using touchscreen interfaces, again, to manipulate many data points at the same time using gestures and touch, right? Not just one data point at a time. And then here is in VR, interacting with many data tables all at the same time. Right? So on a small screen, I have one data table. Right? Here in my 3D space, I have many data tables. And now I want to do multi-table operations. So I can take one table in one hand. I can take another table in another hand. And I can do a union by joining them like this. I can do a join by connecting them like this. Right? And in fact, if I want to do a join on a particular column in the table, I intersect those two tables at the column that I want to join on. So I can use these gestures to do the interaction instead of having to type, like Python, right? Pandas, right? Joining tables, right? And referring to them by their names, and I'd have to remember what the names of the tables are and so on. So again, this is much more efficient to do these gestural interactions than using other kinds of interactions like typing code. Right? Okay, so that's the idea of embodied visualization and embodied interaction, both more efficient than regular visualization and regular interaction on small screens. Right? Okay, now for the good stuff. Okay. So the third level is what we call embodied cognition. The idea here is that, so I told you about this theory in psychology called embodied cognition, right? That we think with our mind and our body together, right? And so what we're observing here is an analyst analyzing many textual documents, right? So each one of these is a textual document. He's sitting in front of a big display space with lots of documents, right? And these are, it's like an intelligence analysis scenario, right? So each of these is an intelligence report, and he's trying to figure out what are the bad guys doing, right? He's trying to solve the mystery, right? And so the way he does this as an analyst is he reads these documents, and he starts to organize them. He starts to create structure. He starts to, ooh, these are all related. Let's make a pile over here. Ooh, these are related. Let's make a pile over here, right? Ooh, this document connects those two piles. Let's put it in the middle, right? So he's building structure out of this textual information. We call this idea space to think, right? Using space to help people think. And so what he's doing is he's using the space as an external memory. I can say, oh, this is very important. I'll put this here, and I remember it's there. And next time I see another piece of information that relates to that, I know where it is, and I can find it quickly, right? Physical navigation. It also provides a semantic layer. As I'm organizing the information, I'm creating clusters. I'm creating linear relationships or 2D relationships, right? I'm specifying maybe right here a timeline, right? So I'm building all this structure by using the space, okay? And we call that space to think, helping people think in space. So that's another important value that this big display space provides. Now, oh, yeah, can you play this video? So this is a high-speed playback of a user doing an analysis on a big textual data set. And what you're seeing is the user creating structure. Right? He's building up a cluster here. He's building a cluster here, another cluster over here. And he's changing that over time as he learns new information. Right? New connection, bring these together. Right? We call this process incremental formalism. That means we're building formal structures over time, right, as I learn about the information. Right, so you're seeing him think. You're seeing his reasoning process play out in space. So that's kind of neat, right? Because it gives us a window. We can see what he's thinking about. Right? We can actually see the cognition taking place here. We can see the user finding clusters, creating structure. Right? Okay, and this is going to be very important in another minute. But just the idea here is that we can see the reasoning process taking place. Okay. Eventually, he gets a very complex structure over time. This is maybe about 1 hour of work by an analyst. Okay. So if we compare that, a big display to a small display, right? So physical navigation on a large display. This is time. This is the document ID of the document I'm currently looking at and reading. Okay? So notice the user reads the documents in order. Right? But notice each time he reads a new document, he goes back and looks at all the other documents. So these dots are the document that he's looking at that time. His eye tracking. Right? And so as he reads every new document, he goes back and compares it to all the other documents. Right? Or read a new document. Oh, yes, is it like this, like this, like this? It goes with this, right? On a physical navigation on a big display. Right? On a small display, laptop, right? Virtual navigation, reading every document, not comparing it to the other documents. Why not? Because it's too hard, right? Because I have to scroll around and navigate in the space and find it, and I don't remember where it is, right? So if you have a small display, I don't make all those connections that I made up here. These are all connections, right? Making structure, right? So when I use a small display, I lose all that opportunity for making connections and finding important new structure, okay? So this is a very important distinction between a large display and a small display. Make sense so far? Sorry, maybe I'm talking a little fast, right? I'm excited about this stuff. This is fun. Okay. Same idea works in 3D. So this one was, the previous one was 2D. Also works in VR and 3D. In fact, let's play this video. And it's the same idea, but now in 3D space, right? Yeah, gracias. High-speed playback of a person doing an analysis in 3D space. Notice he's creating structure, building clusters. Reads each document, connects it to other documents, places it. Right? Space to think in 3D. Works even better than 2D because there's more space. So they can fill in even more documents into their space. Okay? So they can do a larger amount of information in the 3D space than they could in the 2D space. Okay? That's good. So if we do small 2D versus large 2D versus large 3D, slow, fast, faster. Okay? And if we compare the final reports written by the analysts, right, so they're analyzing the information and then they write up a report about what they found. C minus, do you guys use letter grades here, like A, B, C, F? No, how do you do the grades? 1 to 7. Is 7 good or bad? Yeah, 7's good. Okay. 7, right? When they write their report, right? 6, when they write the report. 2.5 when they write their report, right? Okay. Now, why is that? Why does it help them write their report? So when they structure the information in the 3D space, so each of these is a document and a person would be standing in here in the 3D space, right? So notice then when they write their report that they navigate through the space in order to write the report, right? So they take their red documents and they write a paragraph, right? They take the yellow documents, right, and they write that paragraph. And the blue one's here, and then the purple ones are over there, right? So after they organize all the information, then when they go to write their report, they go over here and they write this, and they go write this, right? And they come over here and they write this. And then that is their final report for the project, right, for the problem. And this is what we graded, and this is what they get a 7, right, for 3D. Right? Okay, so does that make sense how the space, the physical space, transforms into their report? Okay, that's also going to be important later. Okay, so this idea also works for processes, computational processes like Jupyter notebooks, right? So Jupyter notebooks, right? Cells, each of these is one cell per window, right? And we can use this now to organize a notebook in 2D or 3D space instead of linear notebook. Right? So what happens when we ask people to do this? So we gave a whole bunch of people a big notebook, and we took all the cells of the notebook, and we just made a pile, just piled up all the cells. And then we give them a big 2D space, and we say, organize the notebook in the 2D space. Right? What did they do? Well, about 1/3 of the users made a linear notebook, mostly linear, right? A little bit of 2D, right? So these are the cells going linear, right? About 2/3 of the about another 1/3 of the users organized columns of cells, right, in their notebook, right? And so that made it much faster for them then to compare, right, cells, right? And then another 1/3, so this is the columns, right? So that's this one right here. And then another third organize their notebooks and have a graph structure, right? Like this one. Data processing, right? And then maybe clustering, right? Different clustering, right? Some results, right? And so they organized in kind of a graph structure like this, with links showing the order of the process flow of the data in the computational notebook. Okay? So about 1/3 used 1D, and about 2/3 used 2D to organize their notebooks, right? So what that says is that the use of 2D space can really help for processes, computational processes, understanding computational notebook processes, organizing notebooks in space. Okay, so that's what the idea of embodied cognition, right? Helping people think in space. Right? Now I want to talk about collaboration. So this is our new visualization classroom at Tech. At Virginia Tech, we have a new classroom that looks like this. This is a big, high-resolution display. And we use our software called Sage. Sage 3, you can download it here, and it'll enable you to use these big displays in a collaborative way. And I'll explain that here. This is a project between Virginia Tech, University of Illinois, Chicago, and University of Hawaii. So when I'm teaching class, and I have slides, right? Here's 2 slides, right? And so what I can do is I can put like maybe 5 slides across here. Right? So when I'm teaching, I don't just have the 1 slide, I have 5 slides, right? And then when the students miss something, they can look back at the previous slides to see what they missed, right? Or they can make connections between the new slide and the previous slides, right? So that's the idea of physical navigation. I can navigate to see the previous slides, right? So that's useful for teaching, right? Now, over here is we were doing an in-class exercise where all the students were doing brainstorming. You know what brainstorming means? Is that, yeah? So each student would write an idea on a window here. And they put their idea up on the screen. And then they organize those ideas into clusters, right? So we kind of have one big cluster here, and another cluster here, another cluster here, and maybe some outliers over here, right? And so the students can use their laptop. See that? Is that right? So the students can use their laptop to type in an idea, right? And send it up onto the board, right? And then they can use their laptops to organize the board to do clustering, right? And so what that means is the whole classroom is interacting together in order to do this exercise of space to think, right? We're collaboratively thinking together, okay? So what we are building here is a collaborative mental model of this topic. Does that make sense? So what we're seeing here is space to think for many people all at the same time. Shared space to think. Okay? So what that means is these large display spaces can have all these same benefits of physical navigation, embodied interaction, space to think for individuals, but also for groups of people. Okay? And so we can measure that. And so we took a survey, right? And so we had some meetings using Sage, some meetings using a projector, right? Like this thing right here, right? Projecting, right? And some meetings using Zoom, right? And so these are the ratings by the students in the meetings, right? And so, so strongly agree, strongly disagree, right? So better, worse, right? Okay? So SAGE, big 2D, everybody agrees, can contribute, listen, attentive, consensus. Right? These are all good things that you want in a classroom, right? Participation, engagement, right? So SAGE enables more participation and engagement. Projector, less participation and engagement. Zoom, less participation and engagement. Make sense? Now, why is that? Why is the projector so bad? Well, I have control. You do not have control, right? If you wanted to add something, you can't, because I'm the only one who can do it, right? But in the classroom, everybody has control, and all the students can contribute at any time. My collaborator, Jason Lee at the University of Hawaii, he says when he teaches, he says, you have to embrace the chaos, right? Because all the students will start putting stuff up there while you're trying to teach. And things are crazy, right? But actually, it turns out to be good because the stuff they put up there adds to the lecture, right? It adds to the teaching, right? And so when we use SAGE, we can have a much better classroom experience, right? Less boring, right? Okay, so that's embodied collaboration. Right? Okay, and the last one is embodied AI algorithms, right? So how do we interact with AI algorithms when we do analytics? So remember I told you the space to think, where I organize information, right? And remember how I said we can see we can observe, we can see the reasoning process taking place. When I make a cluster over here, you know that I'm thinking about a cluster, right? We can do that. We can use AI to observe and learn from the human reasoning, right? So when the user is organizing the information, the AI can observe that and learn from it and help organize the information, okay? So if I build a cluster here as a human, right, I'm saying these things are similar, they go together. Right? The AI can watch that and say, aha, those things are similar. I can run machine learning on that, learn a clustering algorithm, run that clustering algorithm, and add additional information into that cluster. Okay? So here's an example where the human connects these two pieces of information to create a cluster, right? And now the AI learns and adds some additional information into that cluster. So if I think this information is important and goes together, then probably I want to read these next, because the AI is recommending that those are also similar. Make sense? So the space becomes a common ground between the human and the AI. So we can learn from each other by communicating in this space, okay? Humans think spatially, AI learns from space, right? AI computes on space. Now, so one of the ideas here is that we call this semantic interaction, is the idea that I can now give input to the algorithm and get output from the algorithm in this space, right? So as I organize things in here, the algorithm is learning about what I think is important, what I think goes together. Right? If I go in here and I highlight some words, like right there, right there, right there, I highlight, I think that's important. Well, the AI can learn what's important for me, right? If I write some notes, let's see, I have an example here. Let's see, I don't have an example here, but if I can write some notes, I can type in some notes on these documents, and the AI will learn from that as well. So any kind of interaction I do for my sense making, the AI learns from it. Now, so that's what we call algorithmic input. The AI is learning as I'm organizing. Now, we also have contextualized output. So now the AI does some computation and adds some things onto the screen, right? So when I create a cluster, it adds additional documents into that cluster that I might want to read. So it goes out to a big database, and it forages other relevant information and puts it on the screen into those clusters where they should belong, right? So it's putting information into my space to think. So it's helping me think about that information, right? Another example here is automatic highlighting, right? So when the algorithm learns what's important from me, it uses that to automatically highlight keywords that it thinks are important based on what it's learned from me. Okay? And it highlights those right in place, so now when I open up a document, I can quickly read through and see what's important in there, right? So it's much faster for me than to read. So now the algorithm and I are interacting together in this space, and it's helping me find relevant information much quicker. Right? And it's learning what's important based on what I'm doing. Okay, so we call this idea semantic interaction. Brian's going to give another more detailed example of semantic interaction on Friday, I think. But what happens when we observe analysts using this over time is they start with a big mess, right? Automatic clustering, automatic dimension reduction, right? The user starts to organize new clusters, right? Something about Russia Airlines, something about packages, right? Start to make clusters. The AI learns from that, helps to fill in more information, and that helps the person find more clusters, right? So packages, Chicago, fun, Cuba, right? And then later, right, so you see the times, right? After 83 minutes, about an hour and a half, right? Now they have all these clusters all organized. This is junk pile, garbage, right? And they have these clusters over here. This incremental formalism is me learning over time, right? What we see is a correspondence between me learning over time and the algorithm learning over time, so that we learn together and help each other over time. Make sense? I think this is a really powerful way to interact with AI algorithms. What we observe when we run user studies on this is a kind of a high-level versus low-level reasoning, right? Where the AI starts to do a lot of the low-level reasoning, right? The AI does this, finding specific entities, connecting to documents, finding other relevant documents, right? Whereas that frees up the human to do more high-level thinking. So I don't have to do all the low-level stuff. I can think more about the big problem and what we're trying to solve, right? And that enables me to do more high-level thinking and less low-level, because now the AI is doing more of that. Okay? So that enables us to work together better to get more accomplished, right? So I think this is kind of interesting, this division of labor, right, with the human and the AI. I think that's a good way to think about human-AI interaction. Human is doing the high-level reasoning, AI doing the low-level details. And so that's what works out in this incremental formalism process. So I think this is a really important kind of finding here. Okay. So we have a hypothesis that that VR, 3D spaces, will enable even better semantic interaction. Why is that? Well, it's because the 3D spaces have more tracking. Right? It tracks where I'm walking. Right? It tracks my gaze where I'm looking. Right? It tracks my hands. Right? The VR spaces track everything. Right? So what that means is I can use all that tracking to learn. Right? And so now when the user is doing this space to think and they're building clusters, right, and make another cluster up here and another cluster here, it's also tracking my gaze, right? It notices, what am I looking at? And the hypothesis is that what I look at more must be more important. Okay? So that means if I track my gaze, I can predict what's important. Make sense? And so what that means is, as I read these documents, it notices which words am I looking at more and which documents am I looking at more. And it builds a model of the relevance, right, of the importance of the underlying keywords and documents. Right? And then using that model, it can recommend other keywords or documents that I should look at, right, based on my gaze. Okay? So just by tracking gaze, we can actually get some very important information about what's important in an analysis and actually help the user find other related information. So for example, documents and words. So relevant documents are documents that I looked at more, gaze, are more relevant, right? Documents that I tend to look less at tend to be less relevant. Right? Keywords that I look at more tend to be more relevant. Keywords I look at less tend to be less relevant. And then I can use that to make recommendations, and we find that we can get a pretty good precision and recall just by recommending keywords and documents based on gaze alone. Okay? So that's a pretty good for a recommender system, right? Just looking at what people look at. Right? Okay, so that's pretty nice that now we have all these sensors that can track my movement and my gaze and then help me do analysis. Right? So this leads to this idea that I like to call the two black boxes problem. I talked a little bit about this a few years ago when INFONOR was a virtual conference. When we're doing AI-human interaction, I like to think of these as two black boxes. Right? So you know that machine learning is like a black box, right? It learns, it does stuff, and you can't see, you don't know why, right? From the perspective of the user, this is a black box, right? But also, from the perspective of the machine learning, the user is a black box, right? The machine learning cannot see what's going on in your head, right? It doesn't know, right? So we have two black boxes trying to talk to each other, and that's very difficult, right? So how do we help these two black boxes talk to each other? Well, I think this idea of space to think and semantic interaction is a solution, right? Because semantic interaction can enable me to do my reasoning process over here. The machine learning can watch me do the reasoning and learn from me, right? It can watch my gaze and learn what's important to me just by watching me, right? We call this explainable cognitive intelligence. And as the machine then produces results, it can put those results right into my space to think. And so therefore, I can understand the contributions it's making because I can see how they fit right into my space, right? So if I build a cluster, it adds some information to my cluster. I say, oh, okay, that must be relevant to that cluster, right? And so I could read that next, right? And so that's explainable AI in the sense that it doesn't really have to explain much because I can see where it put it and I can see why it put it there because it's connected to all these other pieces of information. So this idea of space to think and semantic interaction can create the loop here that's very efficient. Okay? And so our vision for the future is that we can take this sense-making loop and we can embed a bunch of models in here and have all these models observing me doing my sense-making process, and then have all these models contribute to my sense-making process right in my space to think so I can understand what it's doing and speed up the whole sense-making process much faster using these big spaces either 2D or 3D spaces. Now, probably when I said embodied, AI algorithms, probably you were expecting me to have like avatars, right? Like, here's the AI algorithm, right? Or the chatbot, right? And I think chat is okay, right? It's a good start. But I think chat is not the ideal solution, right? I think a better solution is to embed the AI right into the space and have it contribute to the analytics by watching me so that I don't have to explicitly chat with it. Does that make sense? The chatting becomes implicit just by my gaze, by my interaction, by watching what I'm doing. Does that make sense? So while chats, I think, will be useful, I think an even better way to interact with AI will be through this idea of semantic interaction and space to think. Make sense? Okay, cool. So that's where we're headed in the future, is embedding more and more types of algorithms into this sense-making process, having it observe more and more cues from my actions, having it learn more and more different kinds of models, and having it help more and more different stages of the sense-making process. For example, one thing we're doing right now down here is thinking about how can the AI help me write my report. So you remember, let me go back. This one. So remember the analyst organized the space to think, and then they wrote a report of their findings, right? Can the AI help do this transformation? Right? Can the AI take my space to think and create an initial draft of the report? Maybe, right? Maybe we can use large language models to read my 3D space, see all the information that I've put in there, how I've highlighted and how I've created structures, and transform that into a draft report that then I can edit to improve, to finalize, right? So that's one way we're going in the future, is looking at how large language models can now help make that final step of writing the report. Okay? So if I go back. To where we left off, right here. So that would be right there, the presentation, writing the final report. Yeah. Okay, so that's the idea of the two black boxes and how these large display spaces will help us solve that problem. So that kind of wraps up where I wanted to leave off, is this idea of embodied visualization, interaction, cognition, collaboration, and AI analytics. Using these space to enable me to do these things in an embodied way, taking advantage of my physical capabilities, right? Taking advantage of AI that can observe my physical actions in order to enable these activities for sense-making. And these are some of the key ideas we talked about, right? Physical navigation to navigate the information. Multiple sensors observing all my actions, right? Giving me big space to organize information, to externalize my thought process. Using Sage to enable all of you to also interact with the information. And finally, this idea of semantic interaction, of using AI to observe my actions in order to help me do more analysis. And so that's where I see things going in the future, is more and more of this kind of interaction where it's observing me and helping me do these kinds of analysis. And so with that, I think I'll wrap up and go to questions. I just want to thank all my students who figured all this stuff out, right? They make the world go round, right? Where's Brian? Are you in there? I guess Brian. I forgot to put Brian in there. Okay. And also my collaborators at Virginia Tech, Georgia Tech, University of Hawaii, and University of Illinois, Chicago. I hope this helps inspire some of the students to think about interdisciplinary work that combines computer science, analytics, AI, with psychology, human-computer interaction, information design, interaction design, bringing these ideas together to do much more powerful capabilities, much bigger problems. And I guess the second thought I want to leave you with is that this is measurable, right? I showed you some graphs and some results, right, of improving with time, right? We can do science on this stuff. We can actually measure these effects and figure out how to help people work faster using immersive spaces. So this isn't just cool, right? Remember the picture at the very beginning in the movies, right? It's not just cool, it's not just hype, but it's actually real. It actually helps in these important ways. Okay? So we can do science on this kind of stuff. And so that's why I want to encourage the students to think about that. How can we take these interdisciplinary ideas, put them together, do science on them to prove new, better ways of doing things? Okay? Thank you very much for your attention.
Thank you, Mr. Chris. Vamos a disponer de algunos minutos para hacer consultas. Levantan la mano, le hacemos llegar este micrófono. Tenemos entendido que tenemos traducción simultánea para hacer las consultas, ¿no? A ver. Vean, va a haber traducción, no simultánea.
¿En qué idioma hablo? ¿Da lo mismo? ¿En quechua? No. Hi, my name is David. I was thinking about maybe the placing of the boxes like documents. It's relevant. I think maybe if I put a document behind me, it's less in performance to see that about putting the top. It's your focus on that, or is irrelevant for you?
Sí. Excellent question. So we've done a lot of studies on that. How do people organize in 3D is the question you're getting at, right? So you're right that people tend to use a kind of a semi-sphere around them. They tend to use about 180 degrees, right, of space. So that's where they use that space first. They do use space behind as well, but they use that less, right? So they'll always start with the space that's in front of them. Also, in terms of up and down, we observed that people tend to use space above them also. They start by going like this around them at eye level, right? But then they also use the space up above, which was surprising to us. We didn't expect that they would want to look up at the information, right? But they did not use information, they did not use the space below. So that's interesting. So they did use above, but they did not use below. And I'm not sure why that is. Maybe it's because they felt like they would, bump into it when they walk, right? But that tends to be like if you could picture a heat map, it would be, hottest here and getting dimmer as you go around and getting dimmer as you go up, nothing down below. Now, some of them also use depth, so they mostly put things on a kind of a semi-sphere, right? But some of them also use depth to put things behind. Like when they build a cluster, they put the most important one in front, and then they put less important ones behind. So what that means is the depth correlated with importance or relevance. So we could use semantic interaction for that as well. We could measure the distance from the user and use that to learn relevance. Does that make sense? So it's kind of an implicit relevance feedback mechanism based on how far they put it away. Pretty cool, huh? Yeah, good question.
¿Alguna otra consulta? Okay.
Hello.
Hola.
Good morning. My name is Gabriel Icarta. I am from the Arturo Prat University. And first of all, thank you for your presentation. I saw that most of your examples, you use data source in text form. I mean, paragraph, something like that, yeah? So I would like to know if this is different when you use another kind of format, for instance, images, or maybe from the perspective of an engineer, you use more diagrams to know some relation, because some diagram can influence another diagrams. Yeah. So what is the experience in that kind of data format? Thank you.
Yeah, good question. So I would say most of our work is in text analysis. It's kind of just the area that we like to work in. And Brian will also present some text analysis work on Friday. So most of our examples are in text analysis. Now we also are doing more work now with computational notebooks, right? It's using notebook structures for processing data and using that, right, in the space. So there we've been dealing with like all kinds of numeric data, right? Let's see. Also, we did a little bit with images, not a lot with images. So we use this same idea to process images with a collaborator in agriculture. They take pictures of crops, plants, and they want to organize based on similarity, right? And so we put all these pictures up, and they could build clusters of plants using pictures that way. And then we could learn, we used a ResNet, deep learning algorithm, deep learning model for images, to then learn a model of their clustering of the plants. And we could then predict new images that came in. We could put them into the right clusters. Right? So we did a little bit with images, mostly with text, some with computational notebooks. Yeah. Yeah. So the reason we are doing a lot with text is because we are supported by the U.S. intelligence services, right? And they have a lot of textual information, so they want us to work on that. Yeah.
Thank you. La última consulta.
Okay. Yeah.
Bien.
Hi, Chris. Thank you so much for the valuable, presentations. So, actually, I just want to know about, Sage, SAG, some softwares you have compared with the Zoom. Can you explain about the Sage, just with respect to Zoom?
Yeah. I wonder, is it okay to show the slide again? How much tiempo?
Thank you.
Okay. So the question was about Sage versus Zoom. Yeah. Sage, okay. Compared to Zoom, yeah. Here we go. Yeah. There we got it. So when you have meetings, do you use Zoom? Yeah, so with Zoom, one person can share at a time, right? I can share my screen to Zoom, but only one person. So only one person can be presenting information at any point in time. Serial, right? Serial processing in Zoom, right? One person at a time. So that's Zoom. Same with projector, right? When we use a projector, and I have my laptop, right? And I plug in the cable. I'm the only one that can present because I have the cable, right? If you want to present, I have to give you the cable and you plug the cable in and then you project and you can present, right? One person at a time, right? Serial, right? But with Sage, everybody can present all at the same time. We can both share our screen up here. Like this could be my screen, and this could be your screen. And this could be a student's screen, right? So we can all share a screen at the same time, and then we can compare, right? So one of the things we do in class oftentimes is I have the students compare solutions. So like one student will show their solution, another student shows their solution, and then we can compare the two. Right? Right, so multiple people can show at the same time, and then we can do parallel activity that way. Does that make sense? It is developed by 3 universities through an NSF grant, National Science Foundation in the US supports this. Virginia Tech, University of Illinois, Chicago, and University of Hawaii. And you can download the software here, and you can try it. Now, it works best if you have a big display, but here's the thing, it's really easy to build a big display these days. All you gotta do is go buy some TVs and put them up on the wall, right, next to each other. And then you can use Sage to connect, and then you can have your whole class across all these TVs, right? Maybe Brian could set up a display lab here at the UCN where you could use Sage. So that would be something I'd be very interested in collaborating with you with, if you would like to set up a Sage wall here at UCN. Yeah.
Okay. Good. Sure. Queremos agradecer al doctor Chris North. Queremos invitar a la presidente del Comité Organizador de INFONOR Chile 2023, el doctor Claudio Menezes, a hacer la entrega de un presente, agradeciendo la excelente presentación ante nuestra clase magistral al doctor Chris North y, por supuesto, con el aplauso de todos nosotros. Muchas gracias. Thank you. Thank you. Thank you, Mr. Nos acompaña la directora ejecutiva del Comité Corfo Antofagasta, Melissa Gajardo, a quien queremos invitar a entregar las palabras casi ya al cierre de esta ceremonia inaugural. Por favor.
Un saludo a todos y a todas los presentes. Es un gusto como Comité de Desarrollo Productivo Regional y la Corfo Nacional poder apoyar, impulsar eventos que efectivamente son necesarios para nuestra región y para nuestro Chile, que es la transferencia de conocimiento. Cuando las universidades se acercan a nosotros a presentarnos proyectos de colaboración, efectivamente nosotros visualizamos cómo poder aportar, que no solamente es una empresa, un emprendimiento, las líneas directas que podemos tener, sino que podemos hacer programas en conjunto y colaborar. Igualmente con la salud de bienvenida al gobernador también demostramos que estamos articulados constantemente en esta línea de educación, de transferencia, y no solamente para nuestras nuevas generaciones, sino que también para todos nuestros profesores, nuestras universidades que están participando actualmente en esta actividad, que les permite tener estas relaciones nacionales e internacionales de conocimiento y que efectivamente nos permiten a nosotros poder involucrarnos cada vez más en las temáticas que son esenciales de nuestra línea. Siempre hemos hablado de que nosotros apoyamos el fomento productivo, tanto como en términos industriales, pero efectivamente estamos en la era del conocimiento. Y esta era del conocimiento, tanto como las universidades de nuestra región y de nuestra macrozona norte, han estado aportando para que salgan profesionales cada vez más completos, con ganas de crear, de idear y de ponernos a prueba y hacernos competir a nivel internacional, no solamente con ideas que salgan de acá, sino que servicios que efectivamente podemos mejorar en conjunto, agilizar y, como vimos en la presentación, incluso poder tener participación a través de esta línea muy potente. Destacar efectivamente que hay un diplomado de Internet de las cosas, y eso ya demuestra que las especializaciones que se están visualizando nos están exigiendo no solamente desde la perspectiva de querer un aprendizaje nuevo y coherente con la línea global, sino que lo necesitamos dentro de variables necesidades, no solamente las empresas que están involucradas en torno a la economía, sino que también la misma academia, que requiere que profesionales vayan creciendo en esta línea y efectivamente nos vamos empoderando en la línea de Internet, de la digitalización y en general de todo lo que nosotros queremos en la tecnología, innovación y emprendimiento. Como Comité de Desarrollo Productivo, nuestros ejecutivos, consejeros regionales que estamos co-creando conjuntamente con las misiones de nuestra línea de gobierno regional, estamos muy contentos que estos días se estén realizando en nuestra región. Agradecemos que estas instancias se estén presentando constantemente como desafío para poder trabajarlo colaborativamente y por lo mismo espero que sigan teniendo una excelente jornada, que este es el primer día de 3 y efectivamente saquemos nuevas brechas, nuevos proyectos para poder seguir incentivando como casa esta macrozona norte de Chile. Así que felicitaciones para los que realizaron la actividad, los que estuvieron detrás de ella y también felicitaciones para los que están participando, porque esto se hace en conjunto, tanto como expositores, como estudiantes, como el público en general que está participando le puede dar vida a estas buenas instancias. Muchas gracias.
Muy bien, con las palabras de la directora ejecutiva del Comité Corfo Antofagasta, Melissa Gajardo, estamos llegando al final de esta ceremonia de inauguración de INFONOR 2023. Les agradecemos su presencia y les recordamos que las plenarias y presentaciones se efectuarán en las salas audiovisuales del pabellón K. Dos cositas antes de que nos vayamos. La credencial que tienen ustedes es plantable. ¿Qué quiere decir? No la boten, sino que lleguen a la casa, plántela porque tiene semillas de rúcula, ¿no? Así que les va a salir una linda rúcula con la credencial que tienen ustedes ahí en el pecho. Y lo segundo, queremos invitarlos a compartir un cóctel en el hall del recinto, dando entonces por inaugurado este encuentro de estos días. Gracias, muy buenas tardes.